Thanks everyone. Really nice to join back in with the group again, and hopefully my talk can feed in now with Greg's and Jared and previous talks that you've also heard. So I'm speaking today on behalf of myself and a colleague, Niamh O'Mara. I'm based in the Technological University in Dublin in Ireland, and she's in the University of Limerick in the south of Ireland. And what I'll be talking about today is professional development for out-of-field post-primary teachers of maths, an analysis of the impact of maths-specific pedagogy teacher training. So just one aspect of a program. So as we all know from being part of this network, that the phenomenon of out-of-field teaching has been identified often as a contributor to underperformance in school mathematics, and that's the case in an Irish context. So off the back of that, the professional diploma in mathematics for teaching was developed in Ireland, and it's run out of EpiSTEM in the University of Limerick. So that's a national centre for STEM education in Ireland. The programme is level 8, so it's a degree programme, and it's free of charge for out-of-field teachers to take part in. So they do it after school and at weekends and on school holidays. It's blended learning, so this is all kind of giving you background, and the data I've collected is pre-COVID. It runs in 10 lecture and 15 tutorial venues around the country, so teachers can go to, depending on where they're situated, for the face-to-face, they can go to their nearest centre, and it's offered through the medium of Irish as well. So the programme, again, just some background before I talk about the actual research I've carried out. There's 10 modules run across 2 years, so you can see the different modules there. All of what I'm speaking about today as well is based on a paper that I've published recently, so I can give a reference to that if you want more detail at the end. So the modules run in normal semester time across 2 academic years, and in conjunction with these content modules, we run pedagogy modules. So this is more the focus of my talk and analysis today. So across year 1 and 2, there's pedagogy and research in maths education. This involves 5 maths-specific pedagogy workshops, which are run on Saturdays, and 1 week summer institute that happens during school holidays. And then in the second year, the teachers carry out action research where, a bit like Tracy spoke about a moment ago, they pick an aspect of their teaching that they'd like to improve on, and that's what the project is based on. What I'm going to focus on today is these 5 maths-specific pedagogy workshops. So to give you more detail on those, the workshops 1 to 5, if you look to the left here of this table, these are the focus of the workshops which we run. They all align with how the second level maths curriculum in Ireland is structured. So there's a functions and calculus strand, algebra, number, probability, and so on. And we try to match them up with the content modules that are being delivered at the same time, so that there's some kind of crossover between the content and the pedagogy that they're learning in real time. So what this research set out to do is to evaluate an aspect of these pedagogy workshops. So what exactly did we set out to evaluate? Well, we wanted to look at one component of this CPD program, which was based on teacher self-efficacy and their self-reported teaching style. So they're the 2 kind of prongs to this. So to give you the research questions, firstly, we looked at, does engaging with math-specific pedagogy improve levels of teaching efficacy among out-of-field teachers? And we analysed that per strand, so almost per workshop. And secondly, then, what impact, if any, does math-specific pedagogy have on self-reported teaching practices of out-of-field teachers? So this does very much feed into what Jared spoke about, albeit his was probably done in a more extensive way, but we'll talk about the limitations of this research as well. So to give you an idea of the conceptual framework that underpinned this study, myself and Niamh used Guski's model. This, just to put it in context, the program as a whole is being evaluated. So this is just one prong to a larger evaluation. And this particular aspect of the evaluation of this out-of-field teaching program focused on level 1 of Guski's model, level 2 and level 4. So the participants' reactions, their learning, and also their use of this new knowledge and skill. So that's kind of just giving you a very brief idea of the conceptual framework that underpin this study. The sample size then that we looked at, so there was a total of 207 teachers in this particular cohort, and they completed the pre-workshop questionnaires. I'll talk to you in a minute about what was contained in the questionnaires and how we structured them. Out of those, 152 of them completed the 2-year program in the time frame. So in real time without having to defer or repeat anything. And in total, 91 of the teachers completed both pre and post workshop questionnaires. Sorry, I just want to remove thumbnail. Okay. So this cohort 5, we had almost 60% of the teachers in terms of a response rate. For the quantitative comparative analysis, we're basing it on these 91 teachers. So we did kind of lose teachers along the way, depending on what they completed or whether they completed the program itself. The qualitative data analysis then was collected via open-ended questions on the questionnaire, and the data reported in this presentation is based on all completed questionnaires. So there was valuable insights of those who gave pre-questionnaire data who didn't complete post, and vice versa. So the 91 refers only to the quantitative data. We used a mixed methods approach. So teachers were asked to rate their self-confidence in the 5 strand areas using just a 3-point scale. So if they were not at all confident, somewhat confident, or extremely, and that was prior to and upon completion of the pedagogy workshops. In terms of qualitative data, teachers were asked to describe their approach to teaching mathematics pre and post the pedagogy workshop. So it was very much self-reported description of their approaches. Unfortunately, we didn't get into schools, but that's something, as I mentioned earlier, that we're hoping to kind of advance this work onto. So how did we analyze the data? The quantitative data, we used SPSS first just to look at descriptive stats. But then we compared pre and post workshop responses using Wilcoxon's sign rank test to determine was there any changes in the teacher's self-reported self-efficacy. And for qualitative data analysis, then we gathered the data with on the open-ended questions with NVivo, and we use open coding. So we didn't want to have predetermined set of codes, but rather kind of independently identified codes. And then we use thematic analysis to see what were the main outcomes of those open-ended questions. Okay, so research question 1 then, does engaging with math-specific pedagogy improve their levels of self-efficacy among the out-of-field teachers? To summarize this, I have 2 tables. So both of these figures are from that published work that I mentioned. So I know this is probably quite hard for you to look at on your screens, but the 5 areas reflect the 5 strand areas that our second level teachers teach in the Leaving Certificate, which is the kind of final 2 years of second level schooling in Ireland. And it also maps with the 5 workshops, the pedagogy workshops. So you can see the blue is extremely confident, pre-workshops, pre-engaging. So the teachers hadn't engaged with any of the pedagogy at this point. The orange and white is somewhat confident, and then that gray line towards the end is not at all confident. So you can see it varies depending on the strand area, with like more confidence being detailed in algebra and the least in stats and probability. When we asked the exact same question then in terms of post workshops, so they had completed and engaged in the 5 workshops, and they're compulsory. So all teachers were present for both. You can see an improvement if you look at this. So again, they were asked what's their self-reported self-efficacy, their confidence on that 3-point scale. And the teachers, we found a statistically significant improvement across all strand areas with the exception of the geometry and trigonometry, which although it improved slightly in terms of a smaller proportion of those saying they were not at all confident, it wasn't found to be statistically significant. The largest improvement you might see there with the stats and probability section, and I can talk more about why that might be if people are interested, but it's probably more historical from the point of view of how our Irish system has been run in the past and how we tend to deliver, and where the focus begins and what gets left with little time, which is often stats and probability. So that was we found improvements in that self-reported. When we looked then at the qualitative responses to research question 1, the largest kind of overarching theme was improved levels of math teaching self-efficacy when we looked at these responses. So comments like, it's given me more confidence and a better insight into mathematics. It's given me much more confidence in my teaching ability and my understanding. Teachers also said, as a result of the workshops, I am now more confident with teaching and better at maths. The second most popular response when we looked at the thematic analysis was that it helped to improve their ability as a maths teacher. So references like, I'm now able to explain backgrounds of topics more effectively and improved my teaching ability. So these were kind of reflective of the wider responses. Moving on then to research question 2, what impact, if any, does the workshops have on self-reported teaching practices of out-of-field teaching? Just to give some stats on this, the pre-questionnaire, only 35 responses. We found this interesting in itself and possibly reflective of teachers at the beginning of this process not having the language maybe to describe how they report their own teaching practices at that point. The 2 most favorite approaches, again, when we looked at the NVivo and thematic analysis, were rote learning or a procedural approach, and that wasn't the language that the teachers used. This is how we identified it when we analysed everything. That was mentioned by almost 30% of respondents, and the second most favourite approach, encouraging active learning, was the theme we came up with there. So some sample responses from these themes were things like chapter completion followed by exam questions. That's how one teacher described how they describe their teaching practices. Traditional methods, talk and chalk. So that teacher kind of had more of the language maybe that we might use in terms of maths education, and activity-based in student learning. So that was someone who was in the kind of encouraging active learning space. And only one of the respondents in the pre-workshop questionnaire made any reference to teaching for understanding. So that was interesting as well. In the post-questionnaire then, of note, 92 teachers offered a response here, again, maybe reflective of having the language now to speak about it. The predominant theme or teaching approach described was active learning methodologies by over half of the respondents, and teaching through the use of real life examples by 17%, and teaching for understanding by a further 14%. Now, we're very aware when we carried out this analysis that it could be research bias of those trying to say what they think we want to hear. So we're very kind of open to that. But some of the sample responses from those in the themes, teachers said things like introducing more active learning activities and group work, trying to link everything now to real life examples. And this language wasn't really used pre-workshops, using more meaningful and useful examples and allowing students to develop understanding as to why things or formulas work, which wasn't really in the narrative pre-workshops. So there was definitely a clear distinction noted between the pre and post-workshop practices, despite being very aware of those limitations and that potential bias that was there. So in discussion then, work that was done by Niamh, Palucci and Lyons spoke about how out-of-field teachers lack pedagogical content knowledge. The lack of that impacts affective aspects such as confidence and anxiousness related to effective teaching. And this was found by Hobbs in 2013 as well, and other research. So we felt then the promotion of effective teaching needs to focus on mathematical content knowledge, which, as described by Ball, includes pedagogical and subject content knowledge, as well as teacher self-efficacy. So the professional development in mathematics for teaching, the program that I'm speaking about here, was designed so that teachers could develop that subject matter and content, pedagogy content knowledge simultaneously. And due to the correlation between teacher knowledge and teacher self-efficacy, these two constructs that underpin effective teaching, it was anticipated that this approach to professional development would lead to improvements in not only knowledge, but also self-efficacy. And we feel that this research that we've done does show such improvements in self-efficacy. In addition to that, the research has found that efforts to improve teaching and learning also has to focus on change in classroom practices. And the majority of teachers in this study reported moving from that traditional to the more teacher-centered approach that focuses on conceptual understanding. So we're hoping that we've hit on that to some degree. And we definitely found, when we kind of analysed this in terms of Green and Murtova's description of professional development, moving from transactionalist to transformalist, where the teachers initially kind of accept and understand the need for the change, to the process of actually implementing it, was present here to some degree. So just to finish then, improvements in teaching efficacy as a result of the subject-specific workshops, we do feel was present here. A construct that has definitely been found to underpin effective teaching. We also found a shift from more procedural and teacher-led approaches to more student-centered, that focus on teaching for understanding, which is definitely in line with best practice in maths education on the whole, on an international context. So we hope really that this is one kind of structure for professional development that is working and that we can kind of build on and improve on, but very much interested in extending this work, like both looking at what Greg is speaking about now and investigating and what he might come up with that I can learn from, but also from Jared's work of getting into the classroom. That's kind of where we hope to extend this work to next. So I'm really interested in any questions that you might have or comments, and thank you for listening.